What are thread sealings, and can you really join two pipes in a way that they are more tight than before? Well, today we'll find out all about that. Is it dangerous? So now we have joined another pipe here. You always sell half full bottles.
Yeah.
Welcome to HiFinder Tech Talks, where we understand the technology that makes the hydrogen economy work. My name is Steven, and today I'm joined by Simone Zanetti from Henkel, a company that has worked in sealings for many years, and you've been doing that, I think, for the last 13 years or so. You're a mechanical engineer and absolute expert in everything related to thread sealings. So thank you very much for making it here, and let's go with this.
Thank you, Steven. Thank you for your hospitality, and thank you for inviting me.
Well, okay, you'll be sorry soon. let's go. So what exactly are threaded sealings?
Threaded sealing is one way to join two pieces of pipes together. Two pipes together and seal properly the pipes and avoiding to have any leakage.
Okay, so that's one way. So it means that there are other ways as well.
Yeah,
to join the pipe.
This is one way. There are other type of solution in the markets. Available is not the only one.
Yeah.
For example, here I reported some information from the market. The radial press fitting for metal pipes is one of solution. There are different type of design in that case.
So this is a press fitting. This is where one pipe is bigger and the other one is smaller, and then you basically you just
you press together. You use a specific tool to press, and in this case there is the sealing that is made by an external O-ring. In that case, that is a rubber.
Yes.
And is impossible normally to disassemble the part.
Okay.
And then is a good solution for some things. Rather less is more expensive than other solution, but is a solution that exists.
Okay. And this is welded.
Yes, welding is the other solution. Is very common. Normally is cheaper than other type of solution. Also in this case is a solution that is not possible to disassemble if you want to disassemble the parts. And you need to have an energy. You have to need someone that is able to weld properly the material. And also you have to have a similar material or compatible material to weld together. Okay.
So that means so we're already talking about some advantages and disadvantages. So advantage of a thread seal is that you can disassemble it.
Yeah. Obviously. The advantage of the thread sealing is a solution that is possible to assemble everywhere.
Everywhere, yeah. By anybody.
Anybody can assemble. It's easy to assemble. It's possible to disassemble if you want to, if you need to replace a part, if you want to reopen for maintenance or change one component. It's possible to disassemble.
Yeah. But it can leak.
Can leak.
So that's why you're talking about sealing.
Yeah, exactly.
Exactly. Okay. So let's go right into it. Can you take us a little bit into the details of how this works? Yeah.
The thread connection is normally made by two pipes. There is the threads.
The thread, okay. So
and
see on the diagram, this is the thread side.
Exactly. And when you apply the surface or you joint the surface, you have to seal properly the surface.
Yes.
Because it's impossible to seal without, especially gas, particular gas, without to use the right way to seal properly.
Understood. Okay. So now when you apply this, and I know this, like, how does it actually look on a small? Does the gas go through the threads or does it go around the threads? How does the gas go out?
Yeah, it depends on the situation because there are a lot of cases that can create some leakage when you work with the thread connection. Normally depends on also the type of threads because there are different standards available in the market.
Exactly. I read that like especially when you want to when you have when you want to be tight, you just make it a really small thread. Yeah. And then the smaller the thread, the finer everything is.
Yeah. You increase the surface. You have more threads that maintain the connection. But also in that case is necessary to seal.
Also,
yes.
Even
Yes, because there is the main point is that when you have a thread connection, it's impossible to have 100% of the surface connected.
Okay.
It's due to the fact that there is a necessary gap to join the parts. If in the ideal world is possible to assemble.
Yeah.
With a 100%, it would be impossible to assemble the parts.
Okay, yeah. So essentially, what you're doing is you're trying to fill.
Yeah,
that-
it's necessary
maybe
to
we
have
can-
a small gap.
Yeah, maybe we can just hold this here so the camera can
Yeah.
see it better. But basically, you're trying to fill, and I don't know if you can hear this gap. Okay, good.
And yeah, also in case of perfect connection between the metal parts, for example, in a strong interference, there is never 100% of the surface.
Okay, so tell us a little bit about so the sealing now, and possible things that we can do.
Yeah, when we have a thread connection, it's necessary to choose the right way to seal.
Yes.
Because there are some external situations that can create micro movements or create a different of pressure, for example, vibration, the bending. There are a lot of external cases that
Yes.
can create some problem with the
Yes.
threads.
Okay. Well, we see that on your diagram here.
Yeah.
Yeah. So when there's vibration.
Yeah, the bending, they change, the temperature changes in case of different material for pipes, the pressure, high pressure, or the torque also is.
So I'm interested in the temperature change. So I mean, I know this is metal here, and metal can change, expand and
Yeah,
contract
exactly.
depending on the temperature. So at one time, this pipe is out in the cold, and then suddenly you have this super hot gas or liquid flowing through it. So how would the sealing handle that?
Yeah, because normally with the difference of temperature, there is a micro movements,
Yes.
and then create a leak path for everything, for
Yeah.
liquids and also for gas.
Mm-hmm.
With specific solutions, it's possible to seal properly the surface and cover 100% of the surface, and avoid these micro movements, and be sure that there are no problem in terms of sealing. Exactly in this case, there is a picture that demonstrates that normally there is a small gap between the parts.
Yeah.
That
So
is,
this yellow part.
yeah,
will be
the
the
yellow
gap.
part is the gap that
Yeah,
is
zoom in
necessary
there,
to seal properly.
So that is exactly, yeah.
Otherwise, it's easy for the gas, for hydrogen in our case, or for
yeah.
a liquid
So this
to
is
find
zoomed in here.
the leak path to out.
Yeah, okay.
But in the case that is a MPT or BSPT type of threads.
MPT or DSPT?
Yeah, there are different standards that exist in the market.
Okay.
There are different type of threads, change the angles, change different things.
Okay.
One is most common US normally, the other one is most common Europe.
yeah.
But in both cases, if the customer use BSPT or MPT, there is this type of
Which one
solution.
do we see here?
Yeah, here is a general diagram.
Okay,
And,
okay.
but in both cases, there is this type of gap between the parts because otherwise it's impossible
Okay,
to
alright.
assemble.
Okay.
When there is this type of gap, there is the potential of leak path between the
So that
parts.
means the gas could then go all the
Yes,
way here, or it could meander its way around.
Exactly,
and,
exactly.
So, how do we then go about sealing this now? And I know that you have some, let me say, creative solutions there.
Yeah, in the market there are different type of solution
Yes.
that are the traditional sealing methods. For example, there are the PTF tape. Another solution is a solvent-based solution.
Solvent-based, okay.
Or hemp paste that is normally used in a hydraulic situation.
Okay.
Normally never in the gas because there is no certification that is available for that.
Okay.
But are three solutions that exist in the market.
Okay.
Both of them can have some advantages, but normally in all cases it's difficult to seal properly the surface, especially when we talk about small molecules or high pressure.
Okay, okay. So, can you show us then your solution? Because here you have the
The
tape. The
Typica.
tape, yeah.
The solution that we use normally to seal the threads is an adhesive solution that is an anaerobic. That is a particular type of solution or product that is normally 1K components, solvent-free, with a high chemical resistance, with high temperature resistance. It can go over 200 degrees, sealing properly without any problem. We can cover all the surface because it's a liquid that changes status, becoming a solid paste. And in this stage, when you apply in a liquid status and assemble the parts, the liquid is able to cover all the surface, all the roughness, and create a real connection of 100% between the parts.
So it kind of gels in
Yeah.
between that. Okay,
exactly.
okay. So so if you wanted to apply this here,
Yeah.
how would this work? Yeah.
I will show you. Put
All right. Okay.
Yeah.
Now it's. Is it dangerous? This
no,
material?
it's a chemical product.
Okay,
It's
okay.
always suggest to apply with gloves,
Okay.
especially when you are in real contact with the product.
With the product. Okay. So that means that's why it makes sense to wear gloves and to wear glasses. Okay. I'm already wearing glasses.
Yeah, I have also the
Okay.
glasses. Normally, in the market is a solution that is not so common to wear glasses. Also in this case, but it's something that is always suggested.
Yes.
Especially due to the DPI are reported in SDS for the product.
Okay. So all for
And then,
safety. Mhm.
Yeah,
Okay.
it's better to take the security before.
Okay, all right. So just maybe as you're preparing, we have you see we brought a little diagram. So here, so in the end, you want the material to be like all the way in between,
Exactly.
right? Mhm.
When you apply the product, there is exactly the perfect material that cover 100% of the surface.
Okay,
It's
okay.
able to adapt to all the surface, the roughness. In case of damages, is able to cover also them. And then is why we suggest this solution to seal properly the small
Okay.
molecules in general of gas, but in particular with
Okay.
with
Yeah.
with all the
So
solution.
so what do you have there? What is this?
This is the product.
Yeah, I think you put it over here. Yeah. So okay, that's it.
This
Uh-huh.
is one example of the product. Is a liquid
Yeah.
that remain in this status.
This is a sealing for threads.
Yeah, is
then.
one of
Okay.
the solution to seal properly the
Okay.
threads. Because there are different type of solution. When change the performance of the product, can change the viscosity, the
Yeah.
ability to cover gap.
Okay, so you put it on this now, and I mean, so when it goes in here, it stays like this, or no?
No, it's completely different
It's
because I put here to show that the product is a liquid product that
it's a
is easy
liquid.
to apply.
Yeah.
But in this particular case, the solution works only when there is a contact with metal and the absence of oxygen. Otherwise, the product remain liquid.
So okay, so when here there's air, so it's not
Yeah.
doing anything. There's also
Nothing
no metal,
happening here.
nothing happening.
Also,
But
if
the
we
moment it
wait,
touches
yeah.
metal and you take away air,
exactly,
then it starts to do magic.
Start the reaction. Yeah, start the
Okay, you have to tell us what it's
chemical
doing.
reaction. Then I will show. I will
Okay.
explain a bit
Okay,
more
yes.
how it works.
Okay, so let's see this
How to
happening.
apply?
Oh,
Is
mhm.
easy to apply because
I'm
it's
just
one
gonna-
quick. Yeah,
Yeah,
it's
I
better
think
to
it's
move.
better to move it away. Let's do that there so we can see it better in the camera.
It is
Yeah, okay.
sufficient to apply a ring of product all around the
Okay.
pipe
Mhm.
from the
And you
second-
applied at the end, not there. Okay.
No,
yeah.
no, here.
There. Okay.
Because when I assemble the parts,
Yeah.
I can distribute in better way.
Okay.
Beautiful.
Okay. All right.
It's only a ring.
Mm-hmm.
Take the second part and assembly. Like
Okay.
this one.
Let's do that over here, so we can see that. Uh-huh.
Is why I started from the second one. Because
Okay. So it kind of
due to the
pushes.
fact, yeah,
it,
exactly.
it pushes the liquid as it goes there. along.
Exactly.
Okay. Okay.
Exactly. In this way, we cover the surface.
Mm-hmm.
The product that is liquid adapted to the surface
Yeah.
for the
Okay.
roughness,
Mm-hmm.
and then at the end, start the curing, start the reaction, the chemical reaction,
Aha.
and became a sort of solid plastic that cover 100% and seal properly all the surface.
Okay, so now this thing is there, and
So
this one is actually it's a good test here. We have this one lying here that it doesn't touch metal, that has air. This one is inside there,
yes,
touching metal,
but
having no
here
air.
is in contact with metal, but also in contact with oxygen. That
Outside,
means
yeah.
that
Ah.
outside remain liquid also.
Ah.
What there is inside
Mhm.
start to react, start to become this type of plastic, change the status and become more,
Okay.
more efficient.
So that means, so now the reaction is happening.
Yeah,
How long
Start-
does it take to react normally?
I show you
Mm-hmm. Okay.
when the product, I prepare a couple of pictures to
Mhm.
demonstrate.
Okay. Ah, yeah. Okay.
When there is the product in contact with air, that is this case,
Yes. Yeah.
the product never react.
Never. Okay. So this is what we're seeing here. Now.
Yeah,
okay.
exactly.
Mhm. Yeah.
when you close the product between two metal surfaces,
Yes.
start a chemical reaction that is what's happening here. Inside the resin, inside the product, there are some monomer, the peroxide, and oxygen. That is exactly what's happening here. When the product starts to be in contact with metals, the metal ions that are present in the surface of the metal start to interact with the peroxide and create a sort of free radicals that are the starting point to create the chains of monomers. And then when it's close between two parts, in absence of oxygen, the monomer start to connect to the free radicals, increase their length,
Yes.
and create a lot of cross-link because they start to continuously react till there is a liquid part, becoming something that is really solid, a very cross-link.
Okay, so that means basically the absence of oxygen and the presence of metal causes them to do this. What I would like to know is, I mean, what is actually, are they reacting with the metal? So is the metal different after that, or are they changing their form such that, now they are positively charged or negatively charged and now attracted to one another? Well, how does the actual
all the metal
connection
normally, if as an active metal, exchange metal ions.
Ion exchanges
is exactly what's happened when there is an oxidation on the surface.
All right. Okay.
Because there is a metal ions that is in contact with the oxygen, that in that case create this change of status with oxygen.
Understood.
In this case, the metal ions start to connect with the peroxide that is inside the resin, and start to react. Is something similar, but is a different type of reaction, and is why the performance of the resistance, mechanical resistance, and also the speed of reaction change based on the different type of metals.
Okay.
Because if it's an active, it's faster.
Yeah.
If it's a completely passive metal, is a bit more longer in terms of reaction.
Okay. So this one is still reacting, and it probably will change color when it's finished. Okay, that's
when it's react, became a sort of white plastic.
This is always the nice part about the chemistry, it's turned blue. Okay, it's fine.
You can start from different colors, but at the end.
But actually, we like that, for hydrogen applications, because that then makes it easy to know: is it safe? Has it worked?
Exactly.
Did it not work? Okay. Exactly. Can you tell us where do we find this in the hydrogen economy?
In hydrogen economy, there are a lot of different applications in all the phase of hydrogen. From here, for example, there is the hydrogen generators, and this part, in this part there are thread connections.
Okay, oops, this is so try to zoom in there. Yeah, so we have
a lot of thread connection because there are a lot of small pipes.
All right. Okay.
Connected.
So
also here, for example, different types.
Okay.
Also, if we wanted to see H2 production,
electrolyzer
also
setup,
here, exactly, connected to the electrolyzers, there are the thread connection and pipes.
Yeah, exactly, and some gauges and whatever else you need to put in there.
Yeah, exactly, everywhere. In the transport, storage, and distribution, there are also connection. And in specific case, it's very important to have a real seal surface, because with the distribution and storage, there are also high pressure.
Yes.
And with this type of solution, we are able to seal also application up to 1,000 bar or more.
Okay, so now you're into the numbers. Let's go with that. So this can hold 1,000 bar or more. How do you make sure that happens?
Yeah, because we are proposing some solution. And till now, we say that we are able to seal properly.
Yeah.
But it's crucial to provide to the customer with data that demonstrate that the product, the solution we are proposing are chemical compatible, safe, and reliable to seal properly the molecules of hydrogen that are very, very small.
Yes.
That's why we start to collaborate with external lab in different countries to test our solution in different conditions, in different ways, and to be sure that to have something to demonstrate to the customer with official report
Yeah.
that there is a chemical compatible and we are able to seal properly.
Are there standard certifications for this?
We talk with a lot of certification bodies all around the world,
Yeah.
and actually there is no official standard. There is
Alright.
only one certification body that develop an internal standard that is Kiva. Kiva is a certification
Yes,
body
yeah.
from Netherlands
Yes,
that
yes, yes.
develop an internal standard that is AR214
Okay,
that
that applies.
is used to test and certify the solution, and then we start to collaborate also with Kiva to certify.
Okay,
some,
so Simone, I'm going to go for this because we've talked about standards, but just on a very human point. So if you look at this pipe,
Yeah.
and when we talk about leak-proofness, I
Yeah.
think everyone can see a pipe that was never disconnected has a certain
yeah.
leak-proofness, like this. So now we have joined another pipe here, and I don't know if one can see this, but this is now where the joint is. Yeah? So if I compare this point that has been joined and this point that has not been joined, how would you compare the two?
We can say that
Would it leak here?
yeah, no, we can say that in this part we can prove that there is no leakage, no permeation, because we put material between the parts
Yes.
that cover 100%, but between that material that is a plastic is not possible to have a permeation of hydrogen. That means that in this part we are sure that there is no permeation, no leakage.
Yes.
Something change in other parts of the system because should be a permeation between metals. And a small permeation should happen, but when we put this product, we are sure that there is no real permeation.
Wow, that's a big statement. So that we are sure that on this side there's, let me say, no permeation here, but here we are less sure because
Should be in the time, yes, especially in the
yes,
tank, it is necessary to protect, to
Wow.
create a coating inside because there is a permeation between metals.
Yes.
In this case, is like we use a sort of coating in that part that we protect from the permeation that part.
Okay. Super exciting, and I think this is great also for the hydrogen economy. Now, you said before that when you weld, you can disconnect. Can you disconnect this?
Yeah, it's possible to disconnect. There are different.
Even though it has changed its form now and it has done all the whole chemical reaction and all that stuff.
Yeah, if
How do you disconnect it?
Yeah, if the chemical reaction doesn't start or start after a few minutes, it's possible to disconnect to reply. If the product is completely pure, it's possible to disassembly. It's important in that case choose the right product with a different strength, if high resistance, medium resistance, or low resistance. But in every case, using the temperature is possible to disassembly.
Okay, so let's say you heat it up and then that can do
to normally at minimum at 250 degrees.
Okay.
But with metal parts it's not a big problem.
Okay.
And with the temperature is possible to disassemble the parts.
Okay, so by heating it up or doing other things, okay. So that, because I mean, if you make it that tight, the question is whether you can also open it again. So the time is really running on us. Tell me, give us an outlook. Where is this going? Where do you see the future of this, of threaded sealing? Will we have thread seal everywhere?
We have in all the stage, in all phase of hydrogen. Also in the final use, there are a lot of application threads because thread connection is normally used everywhere.
Everywhere, okay.
From the boilers to electrolyzers to hydrogen generation to metals. All the components are connected normally with the thread connection, and it is essential to seal properly that connection.
One thing that I noticed, and I think we talked, and I want to mention it here, is like, so you said this thing actually only works in the absence of air. Yeah. And I know that you brought some of the products, and we were wondering why is the bottle half full only.
Okay.
And you explained that to me. You always sell half-full bottles because you want there still to be air. Because when it's full, there's no air, and then the thing can actually
especially in this type of bottle, when you can hear that the bottle is full only in the middle.
Okay.
Because is a product that remains stable in presence of oxygen.
Understood.
And is why there is a sort of area that with oxygen to maintain stable the resin.
Okay.
And also the bottle is made by a specific product as low density polyethylene that give to the product the possibility to receive oxygen.
So it would be a bad idea to sell it in metal bottles.
Yeah.
Okay. Well,
It's better to avoid it.
So, guys, you must be careful of Simone. He sells half full bottles, but these are absolutely helpful, and we hope you've enjoyed watching this and learning something about thread sealings that you can obviously, or thread sealings that you can seal with half full bottles. Thank you for watching. If you like this, please give us a like or subscribe to our channel, and you can go to highfinder.com where you can find more products like these that are there to solve technical problems in the hydrogen economy, which we believe is growing and is helping to make the planet greener. Thank you for watching.
Thank you.
And have a wonderful day.
Thank you very much.
Thank you.